Chapter 11, Section 3, Exercise 6. Let's talk about the projection of U onto V. This is the notation. Note that if we were to, in this notation, interchange the U and the V, we'd have the projection of V onto U, which is a different matter. But here we have the projection of U onto V. So let's figure out how we draw it to begin with. Extend a dotted line from the tip of U until you form a perpendicular with V. And then W1, the name we're giving the projection of U onto V, is the vector from the origin to the point where that perpendicular projection reaches V. So W1 is the projection of U onto V. The projection of U onto V is calculated by the following formula. U dot V divided by V dot V, which is also the magnitude of the vector V, quantity squared. And so far what I've written here is a scalar times the vector V. This is equal to 3 times 4 plus 1 times 6. We computed U dot V in exercise 2. V dot V, 4 times 4 plus 6 times 6. You'll remember from exercise 2 that the magnitude of V was square root of 52. So V dot V is that quantity squared, in other words, 52. So the projection of U onto V is 9/26 V. Quickly making the calculations, we have here the final form of the projection of U onto V. Note that if the angle between U and V was more than 90 degrees, the following is a way that we would draw the projection vector. First, extend a line through V, and then again draw the perpendicular from U down to this line that goes through V. And then the projection vector would be this black vector that I just drew. Now the vector component of U orthogonal to V, also known as W2, is the following. And so you can see from this that W1, the projection vector, plus W2, the vector component of U orthogonal to V, what does that give you? That gives you U itself. So it's an easy computation to find the vector component of U orthogonal to V, since we already know the projection vector. Subtracting W1 from both sides of this equation, we get W2 is equal to U minus W1. U is 3i plus j. W1, the projection vector, is what we just got done computing a moment ago. The result of which 21/13 I minus 14/13 j.